All right. Now, so I spent 25 minutes on the sinusoid. Why? Okay, so we got to speed it up. The first reason is this. The Fourier says that we can decompose any signal, periodic or not periodic, into sum of sinusoids. Okay, this is the most important statement. This is why we are interested in sinusoids, because any signals can be decomposed into here. And then, not only that, because we are interested in the frequency of the signal, like you already know, the first one, low frequency, second one, high frequency. How do you know? We say, okay, we can decompose a signal and say that, okay, the first one is at maybe 200 hertz, the second one is at 500 hertz. And then we know. When we know the frequency content of the signal, we can do many things. We can throw away the signals that are not important, or we can remove the signals that are not important, and then we can do compression and feature extraction. Here, another interesting thing. Why are we interested in sinusoids? The name is, it is an eigenfunction of an LTI system. We don't know what's the system yet, so you all just think of it as the continuous time signal that you have learned in the second year. What is a eigenfunction? Function you know, which is something f of t, f of x. So what is an eigenfunction? It means that when I send a signal into a system, for example, I send a signal here, and out comes what I see. The signal here at the output and the signal at the input has almost the same characteristics. What are the three characteristics of a sine wave? The amplitude, the frequency, and the phase. Okay? When I send a cosine wave in, out will come a cosine wave of exactly the same frequency. So what else can change, guys? There are three things only. The amplitude, the frequency, and the phase. So if the frequency cannot change, only the other two guys can change, the amplitude and the phase. So what does it mean? It means when I send a cosine wave in of one frequency, for example 100 hertz, out will only come a 100 hertz cosine wave. Okay? Because input is only 100 hertz cosine wave. All right, Ken? So remember what's the eigenfunction, guys? Eigenfunction is something going in. In this example, it's a 100 hertz signal of amplitude A and phase shift theta. Out, 100 hertz, same 100 hertz, nothing else. No 200 hertz, no nothing. But the amplitude is changed. The phase also changed. So this is called an eigenfunction. And we are very interested in this. If you put your head to this point and this point, then you realize that something magical will happen later on. Okay? And finally, so what are we interested in? For LTI system, theoretically, we can send one frequency in, measure the amplitude and the phase change. Send the second frequency, amplitude and phase change. Third frequency, amplitude and phase change. For all frequency we send, what do? We know how any signal will behave when we send through the system. Can you see? So it's quite important.